here's our next identity to try to prove. It's, again, an even numbered problem from the textbook. So this is my left-hand side here, and this is my right-hand side. Looks to me like the left-hand side is more complicated, so I'm going to start with that one. Okay. Remember, this version of it, I'm going to have to rewrite, because this is connected to the right-hand side, and I don't know that that's true until I've proved it. So I'm just going to say the left-hand side. Now, labeling it as left and right side is optional. I find it helpful. Okay. But it is necessary that I write what it is that I'm starting with. So it's cotangent over cosecant minus cosecant over cotangent of x. Okay. I'm going to write everything in terms of sines and cosines. Okay. That is generally my go-to strategy if I don't see something else to do. Now I could, the other option would be to get a common denominator and combine these. But I'm thinking I'm probably going to ultimately want to write things in terms of sines and cosines. So I'm going to choose to just do that from the get-go. If you preferred to get a common denominator in terms of cosecant and cotangent, that's totally fine. Okay. So I'm going to say this is, now I'm going to create some complex fractions here. Cotangent of x is cosine of x over sine of x, and cosecant of x is 1 over sine of x, minus cosecant of x is 1 over sine of x, and cotangent of x is cosine of x over sine of x. Okay. Now each of these is a fraction divided by a fraction. But I know that the way I would divide by a fraction is to multiply by its reciprocal. So I can say this is equal to cosine of x over sine x times sine x over 1, multiplying by the reciprocal of that, minus 1 over sine x times the reciprocal here would be sine x over cosine x. Now that's kind of nice because my sines are going to cancel. So this is cosine x minus 1 over cosine x. Of course, this is true whenever the original is defined. If sine was 0, these would be undefined. Okay, but when we're working with identities, we're saying everything is true when everything on both sides is defined. Okay. All right, so I'm thinking now perhaps we want to combine to get just one term because I'm sort of looking ahead. I'm trying to get to this. Okay, so I can say that's cosine of x over 1. So I'm going to say this is cosine of x over 1. I'm going to multiply that by 1 in the form of cosine of x over cosine of x. And that's minus 1 over cosine of x. Okay, so that's going to give me, let's see, I'm going to bump over to here. Okay, so I'm going to say we got to here, picking up over here, that's equal to cosine squared x over 1 minus 1 over, I'm sorry, cosine squared x over cosine of x minus 1 over cosine of x. Okay. So now, with a common denominator, I can write that as a single fraction with cosine of x in the denominator. And on top, I have cosine squared x minus 1. Okay. Thinking I should be able to simplify that, I might want to do a little bit of side work, though. I'm seeing a 1 and a trig function squared, and that makes me think Pythagorean identity. So here's a little bit of side work. I know that sine squared x plus cosine squared x equals 1. So if I wanted to get to cosine squared minus 1, I'd want to move the sine squared over to the other side and the 1 over to this side. So cosine squared x minus 1 is going to equal the opposite of sine squared x. I just subtracted the sine squared over and subtracted the 1 over. Okay. So I can say that's negative sine squared x over cosine x. Now, I could certainly keep going. I might be able to see how to get from that to negative sine x times tangent of x. But I promised I wanted to show you the 3-paragraph method. So I'm going to say, you know what? That's about as simple as I can get it, writing it in terms of sine and cosine. So I'm going to stop there. That's my left-hand side. Now, new paragraph. The right-hand side, and there is no equal sign connecting this to the right-hand side. This is a totally new paragraph. I've run out of room. I would just keep going in the next line. If I had more room here, I've had to move to the right just because I ran out of space below here. So that was negative sine x times tan x. And I'm thinking I want to write everything in terms of sines and cosines, just like I did here. So that's negative sine x over 1 times tangent is sine x over cosine x. Oh, well, that's negative sine squared x over cosine of x. Now that's the same thing that I got right here. I'm not done, because all I've done is shown that the left-hand side is that, and the right-hand side is that. I need to state third paragraph, left-hand side equals the right-hand side. You might say, that seems silly, that's pretty clear, but sometimes these identities take a while. So maybe you finished up simplifying the left-hand side on your first page. You simplified the right-hand side on your second page. By the time you're done with that, you've forgotten what the left-hand side simplified to. In this case, it didn't take us very long to simplify the right-hand side, but you don't want to make your reader do the work for you. It's your job to explain why they're equal. So if you point out, hey, the left-hand side equals the right-hand side, that's like, oh, there was a connection between these two separate things that we did. Ah, I see it. They simplified to the same thing. So they are, in fact, equal. Okay, excellent. I should point out, there is no one right way of proving an identity. So if you say, I didn't see that, I would have done things differently, quite possibly you would have done things correctly as well. You want to go with whatever you see that you can do that's going to simplify one of the sides. Okay. And as I said, when you get stuck and you're like, I don't see anything, switch to writing everything in terms of sines and cosines, and that usually makes it easier, because then instead of having 6 functions that you're dealing with, you've